Hello guys, welcome back to this new video. In this video we are going to start our Python. In last video I have given you the introduction to our new programming language Python and setup required to start this programming language. If you haven't yet checked it out, so please go and check out the setup to start our programming. So let's get started without any lag. So firstly, let's write a first line of code. So let's run it. Um, yes, we can see our output, hello world. So let's see what is happening over here. As I said in previous video, Python is considered as high level programming language and it is very easily readable when compared to other languages. For example, let's see this: print hello world. Just by reading it we are understanding what the program is doing, printing the hello world. Print is our function. We'll learn later about functions, but let's just remember print is our function. Its work is to give output of this thing, that is our hello world. We are giving input, code is running it, doing some process, and we are getting our output. So this is the basic process. So for your familiarity, let me give you an example. We use Google. We use search engines. It might be Bing, Google, Chrome. We search something. Then Google processes it. After that, we get some uh, familiar results, related results. We get some links that we are searching. So our output would be links. We are giving search as an input and we are getting some output links. This is a basic programming code works. We give input, code processes it, and we get our desired outputs. Python character set. What is a Python character set? In Python, it's not like we can use every symbol, every word. It's not like we can use some Espanol letters. We have a specific data set that would be letters ranging from capital, right? Hmm. Capital A to capital G and small a to small g. All digits, some specific symbols. We can use some blank spaces and every other as, as ASCII and Unicorn characters as part of our data or literals. Next, we have variables. What are variables? In our high school mathematics, we learn something as variables. Let that be x plus, let that be x plus 2 equal plus 2 is we have x plus 2 is equal to 0. We use x, y, we use variables, right? In similar fashion, uh, we have variables in computer programming as well. A variable is a name of a memory location that stores specific type of specific value. uh, let this be x. In this we can store numbers like 1 2 3 or abc, anything that our Python character set allows, we can store it. That is our variable. Donald trump, and we will try to print it out. Print uh, name. Let's just run. We are getting our output as Donald Trump. Mhm. Next, again, we will make some more variables. Age equal to 80, and let's keep uh, tariff is equal to 15.99. Let's try to print them out. Mm, Age and tariff. Okay, let's just run and see what we will get. And yes, we got our output. Uh, Donald Trump 80 and 15.99. Yes, this is our, we make our variables, we initialize it, and we give some input to it, and uh, we can output it through our print function. Let's so this was our variable. Let's see rules to define our identifiers. Variables are also known as identifiers. So here we can see identifiers can be combination of uppercase, lowercase, uppercase letters, lowercase letters, numbers, and underscore. So let's try it. So here we can see we have all uppercase letters. So yes, here we can see all uppercase letters. Let make it lowercase. Yes, here we can see all lowercase letters. Let's make one of the letter as uppercase letter. Let's see what happens. And yes, still it is functioning as usual. We can change it of any type. We can change like any letter to lowercase or uppercase. It won't be a big issue. See, as we run this, we are getting same output without any vary. So let's do one more thing. We'll make another variable name as age. We'll make it 20, and here we will give normal age. Let's see which one of the following will be implemented. And yes, we can see this age 20 is implemented because every variable is case sensitive. Changing a case of a uh, changing case of a letter can make it a whole new separate variable, will make it a different variable. So yes, it is a new variable and it got outputted and we implemented our output through print function. Next, an identifier cannot start with digit. So let's make it one age. Let's see what will get some error. Will it be implemented? Yeah, we got an error. Line 2, one age, syntax error. As we cannot start our variable name with a digit, it is invalid. But here we can use 1 and it would still be valid. We will get no errors. Yes, we got no errors. Code is implemented and this is totally acceptable. Next, we can't use special characters like exclamation mark, hash, at the rate, etc. Uh, a variable can be of any length. Let's try it. Tariff underscore on India is 15%. Control C. Control V. So let's try to run this. Yes, we got no errors. This is totally this this is to yes, we got no errors. This is totally fine. And that's it. It probably won't be a good idea to name your variables this big, but still we can name it. So next up we have data types. In data types we have several data types. First one would be integers. Integers are nothing but numbers that are from negative infinity to infinity. Next we have strings. Strings are set of characters like hi, hello. Next up we have floats. Floats are our numbers but in decimal form. 1.2, 3.14, 6.686. Boolean as Boolean contains only possibility of two values, that is true and false, and the last one would be none. None itself is a data type. So these are the following data types that we have. So here I will show you how to find what types are our variables are. So since we have our variables, we will use our type function and just run it. You will see, yes, what what is the type of our variable name? It is string. In similar way, we will try to find type of every function, sorry, every variable. So let's run. Yes, here we can see class string, int and float, and let us see a boolean type. Yellow here equals to true, and we will try to print it. Let's run. And we can see class pool. So this is how we can check our data types. And
As generally the word keyword suggests a word that contains a specific definition. In similar manner, in programming, the keywords means set of words that contain specific role for them to do. We can't use them as variable generally. We will explore these keywords later, but for now just remember these are the words we can't use as our variables. And since the variables are case sensitive, we can't use async, but we can use async with S capital or with A capital. So since they are case sensitive, we can't use these exact words, but we can use by changing any of the letters to uppercase or lowercase.
and let me show you example how we can't use keywords. For example, let us take this yellow word as async, async. It would actually it won't be possible. Let us check. We will get an error. Yeah, you can see we got an error. So what we will do is, yes, we will change this letter to uppercase, and now we can see our code is perfect. So this is how keywords are reserved and we can't use them as variables.
So next up, so here we have best practices to follow. What are the best practices? First one would be use simple instructions. Simple instructions in the sense break down logic. Break down logic. So if you break down logic into smaller parts, it would be easier for us to debug and test run each cases. Short and meaningful variables. Use short variables and meaningful variables. As earlier I said, there is no limit on the length how big a variable can be named, but keeping it short and programmer friendly, it would be good. Use appropriate using appropriate comments in the sense use comments everywhere that it is required. For example, in beginning of every function, to let other developers know what does that particular function do, what does that particular function help in, wherever required. In breaking down commenting down the logic would help other developers help to understand the logic easily. Avoid complex expressions. Avoiding complex expression. Let me give you an example. For example, we have a number a and we want to increase it by 1. Just we want to increase a by 1. That's it. After increasing it by 1, then we need to again assign it to a itself. So a is equal to a plus 1, or else we can just do a plus plus. In fact, both of the expression meant same, but other one looks less complicated. This is what meant by avoid complex expressions.